Hi, my name is Erick Velez, and today I'll be talking about Clang-Doc, where we've been and where we're going. So this is work that I did this past summer for Google Summer of Code. I'll be talking about what, why, and how in regards to Clang-Doc, then recent improvements we've made over the last year, and future work still left to be done, and then how the community can get involved. So what is Clang-Doc? Clang-Doc is a tool that lives in ClangTools Extra. It's a documentation generator that started in 2018. And the lightning talk was actually given that year at LLVM dev meeting, but this is really the first time since then that it's being talked about. And it generates HTML, Markdown, and YAML documentation. So why another documentation generator? Doesn't LLVM and Clang already use Doxygen for its documentation? Yes, but a lot of other languages supply their own documentation generators, most notably Rust with RustDoc. You know, it's kind of the ubiquitous documentation tool for Rust. So we think that it'd be great if Clang and the LLVM project could produce their own tool like that. And compiler frontends are really the perfect tool to generate documentation, right? Clang already inherently gathers all this rich symbol information, so Clang really seems like the perfect solution for that. Okay, so how does Clang-Doc work? Here's a graph of Clang-Doc's original architecture. So using the Clang AST, we visit all these declarations, we serialize information from them that we need, like type information, qualifiers, things like that. Those are then created into infos, which is Clang-Doc's most basic data structure. Those infos are written into bitcode. And later, once all this visitation is done, they're read back in, reduced, so following a map reduce pattern. And then the set of reduced infos is then passed into the respective backend. So again, YAML, HTML, Markdown. And those backends handle all of the writing to file and things like that. So Clang-Doc is a libtooling-based tool. So using libtooling's all-to-use executor, we're able to leverage hardware concurrency. So we run a bunch of front-end actions in parallel. They all spin up a recursive AST visitor, and each one visits the decl, serializes information, creates an info, and then writes the info back into bitcode, and then adds them into an index. And that index is later reduced as well. Clang-Doc uses bitcode, again, with this kind of performance in mind, with all of the infos written into bitcode after visitation. We don't have to hold all these infos for thousands of declarations in memory. They live on disk for a while, and then we read them back in, and then similar infos are they're read and then reduced into a single info. So this is what Clang-Doc's original HTML documentation looks like. It's not the best, right? But for kind of like a minimal thing, it's okay, right? We can see that at least it shows classes, classes functions, and some navigation. Most notably on the left side, you can see that on this class page, for some reason, every single class that exists in this project is actually listed there. So this page takes I don't know, 5 to 10 minutes to even load. This is some class in Fuchsia's documentation. So there's like a million classes listed in that on that sidebar. So not great. But why not just iterate on that output? We could make that a collapsible list. Just take that sidebar, put it in a better, like an index page, it doesn't have to be there, maybe spruce up the CSS. It turns out it's not that simple. So Clang-Doc has a weakness, and it's actually in its backend architecture. So unlike in LLVM, where we have like LLVM CodeGen, which promotes code reuse and gets rid of a lot of redundancy with not having to, acting as a library, Clang-Doc has no such thing. So each of these backends actually does everything completely independently. So in every single backend, you have to implement support for documenting classes, for documenting every single type of function. If you want to say like Clang, C++20 had just come out and you want to support concepts, you have to go in and write code for every single backend to document concepts. So that's not great. Also, like I said before, every single one of the backends also handles its own file writing. And that's because every single backend has to handle the specifics of like YAML syntax, HTML syntax, so on. So this is an example of what that backend disparity kind of results in. So as you can see, the top is from the HTML generator, the bottom line is from the Markdown generator, and this is dealing with documenting an info's parents, right, a class's parents. So both of these lines call this function called genReferenceList, but they return different values. The HTML call returns a vector of unique pointers for some HTML node, and then the Markdown just returns a standard string, right? So if you work in HTML, then you have to deal with these HTML specifics. And you can't translate that easily to, say, Markdown, where you're just expecting a string back and just outputting that to the outstream. Also, genReferenceList isn't even a proper interface. It's not actually declared anywhere, like shared among the backends. It's just really like an informal agreement to say, we're going to call this function genReferenceList, and hopefully all the other functions are called the same thing. Bit of a trick question, but what does this web page look like? What is this? It's C++, right? It's not even a web page. So this is how the HTML generator actually generates its HTML. It's a bunch of C++ code that is not easy to easily like reason about the HTML that it results in, right? We can't really look at this and say, okay, this is going to be like the navigation bar or something. You know, this is a bunch of C++ that we have to parse ourselves and actually compile documentation before we see what this will result in documentation. So not great to deal with. Also, like if a contributor wants to, like if they saw our HTML documentation from before and they said like, hey, I want to make that better. Well, then we point them to this, right? And if that person is like a great web developer, they're probably not going to be able to help us, right? Because then they have to deal with the C++ code that I don't even know what it really does. Okay, so let's talk about some improvements over the last year to address these issues. So, like I said before, you know, with libtooling and with the bitcode stuff, Clang-Doc was really written with performance in mind, but it ended up not really resulting in that. So, documenting LLVM, even like on a decently powerful machine, could take, you know, 10 plus hours and hundreds of gigabytes of RAM. So, as part of GSOC from last year, some major performance improvements were made with memoization, right? So as you can see on the graph on the left, our mean runtime goes down, which is great. And the graph on the right, it's kind of what we expect with libtooling and using an all-to-use executor, right? As we increase the number of threads, our mean runtime goes way down as well, so awesome. As part of GSOC from last year as well, the contributor introduced Mustache, the Mustache library, which is a really simple templating engine. And that actually is in LLVM support now. And so using Mustache templates, which have a very small specification, we actually have HTML files that live in Clang-Doc. And now we can reason about HTML in real HTML files. So now we have this HTML file with these placeholders denoted by the double curly braces. And so at compile time, when the documentation is compiled, then these placeholders are obviously populated with all the stuff. So this will say something like, you know, class, AST visitor. And the great thing about Mustache too, you know, it's simple, but it has like iteration. So now if you can see that block, the pound public members, you know, that's going to iterate over an object's public members, and we know what that specific block will look like for all these public members, right? So we can reason about the HTML more generically and visually. So old HTML versus new HTML, right? We actually have HTML now, which is awesome. And this is what the new HTML looks like now. A lot better. Still has lots of ways to go. But, and we also designed this based off of last year for GSOC as well. There was a project to redesign LLVM's website. So we kind of styled it after that. And again, no more like million classes on the sidebar. And this loads reasonably. OK, so now I'll talk about addressing the backend disparity, which is the work that I did this past summer. So I introduced a JSON generator and JSON as a kind of an intermediate representation. So now we have a backend that outputs this JSON. So as you can see, this is documenting a IV visitor, and you can see the info type, all sorts of different stuff. Is this type def? And what this allows us to do is, this improves modularity in Clang-Doc. So now we have a separate place where we can validate a project's documentation. Are we properly documenting all of its entities and validating there? And also, it kind of goes along with the spirit of LLVM, right? Where we want to treat everything as a library. So now we can output JSON separately, and we don't even have to necessarily output HTML, right? If someone wants to just deal with the JSON, maybe feed it into a different tool to analyze it there, they can. Or they can continue with documentation generation through our Mustache templates. So this is the new streamlined architecture that results from JSON generation. So again, we have visitation, serialization, our bitcode and reduction operations, but now we have JSON generation. And like I said before, it could stop there if you just want JSON for whatever reason. But if you want HTML documentation, then the JSON is then fed into our Mustache template files. And then the idea in the future is to use these Mustache template files to generate other documentation for our Markdown. So now we don't need Markdown syntax to live in a C++ file, right, to generate the Markdown. The Markdown can live in its own file as a template file, and then we just populate it with JSON. Some other things I did over the summer too, so I supported, implemented support for concepts, global variables, friends, which are pretty basic C++ constructs, but surprisingly enough, they were not supported. I also revamped Clang-Doc's comment support, so comments are treated way better. And then I also, towards the end, started to implement a Markdown parser. So in the future, hopefully we can have Markdown comments that have Markdown in them in like source code. The Markdown will actually be rendered. And one huge benefit, one thing that I benefited from my own work was actually the JSON generator, right? So now, instead of testing HTML code or HTML output for documentation entities, like is this concept like well documented? I didn't have to test the HTML. I just tested JSON, right? So it really sped up development. Future work still left to be done. Cross-referencing, so like in Doxygen, where you have like this function was called here, or this class is used here, things like that. Clang-Doc actually doesn't have any support for that. We definitely need that. Also, improving comment support in the Clang IC. There's actually an issue open for this. So certain comments in source code are thrown away in the AST. So if they're free, if they're not attached to a declaration, say like there's like 2 new lines before and after it, that comment is actually thrown away, which is bad because in Doxygen, it has support for certain documentation grouping in Doxygen pages. So, and that's actually used by LLVM in certain files. So It'd be great if we can modify the Clang AST to actually recognize those in some way. And like I said before, transitioning other backends to Mustache templates would be great. Okay, so how can the community get involved? Well, first, we'd love you to try out Clang-Doc. So the way that you can use it for larger projects, or just the way that you usually compile like Clang, you can call Clang-Doc, choose a format like JSON, specify executor all-to-use, and just point it to a compile commands JSON file. If you just want to like try out a single file, you can do that too. On the second line, call Clang-Doc, and then just specify the executor to standalone. And we have a bunch of other options too, like you can point it to a repository URL. You can supply your own style sheets if you want, so you don't have to use our default styling. So you can check out our docs and you can see all of our all the options there. But we definitely want the community to get involved. We don't have any users, so we need users to tell us, what they'd like in documentation. What don't you like about Doxygen, or what are you missing in Doxygen? And we can try to support that. Right? We're at a very malleable stage still, so we can keep those things in mind as we're continuing to improve Clang-Doc. And we have a lot of areas for improvement. We have a lot of work to do, as you saw. And so we'd love contributions. I think Clang-Doc is a great place for first-time contributors as well, because it's a smaller code base, but you still brush up against and interact with the AST, right? So if you're kind of intimidated by Clang, I think Clang-Doc is a great place where you can get your feet wet. Yeah, but check out our docs. You can also check out my LLVM blog that I just did for the past summer. Also, thanks to my mentors, Paul Kurth and Peter Hosek, for encouraging me to be here. And yeah, thanks. Any questions?
Yeah, so how many people are working on this right now, would you say?
2. It's the lead maintainer, which is Paul Kurth, and me.
Okay.
Yeah, and I just started this summer, so. So we need a lot of help.
Are there any plans to host a Clang-Doc version of LLVM and Clang similarly like we do for Doxygen? It might not be as fully featured at the moment, but I think having that dogfooding available would make it easier for people to see things that could be improved and then just go ahead and improve them.
Yeah, for sure. That's definitely been talked about, setting up a build bot maybe to just generate LLVM or Clang documentation so that people can look at it. Yeah, that's definitely planned. We have to work out a few kinks first. We tried that and something happened. Something blew up. So
Awesome.
Hi, thanks for the talk. As a part of adding JSON support, did you look into Clang Extract API? Because it looks like it does serve a very similar purpose. And if you have, do you have any thoughts on whether those two tools could use the same underlying machinery if there's complications around what exactly you want to encode and if that is not the same?
yeah. So funny question is that I actually worked on Extract API for GSOC 2023. And I actually added the C++ support for that. Those two are not compatible as far as I can tell. Extract API, so when we serialize our JSON documentation, we actually have is this a type def, and as Boolean values and things like that. As far as I know, at least when I worked on it, Extract API serializes all their info into actual text chunks, which I think they call declaration fragments. So the way that we actually generate our documentation, yeah, it's pretty different. As far as I know, they're not really that compatible. It's something that I considered at the start of my summer as well.
I think we can thank Erick for the great talk.
Thanks.